Assalamualaikum and hi everyone. So next week we will conduct one experiment to study about the interference of sound waves. So in that experiment we will investigate the relationship between manipulated variable, which is D, and the responding variable, which is X. So what is D and what is X? Okay, so this is the theory of the sound waves. First, we learn about the air molecule as the medium to transfer the sound. So we have the loudspeaker here, and then when the diaphragm in the loudspeaker vibrates, the air molecule also vibrates parallel to the direction of propagation. Okay, so the displacement of air molecule to the back and forth represented by a sinusoidal graph. So this is the sinusoidal graph, or we can say as a cosinus graph. The diagram here, it shows the movement of the air molecule. Sound wave is a longitudinal wave where the movement of air particle is in parallel with the propagation of the wave. Okay, we continue. As we can see here, the air molecule is dense or in certain parts. Okay, so at this part we name it as a compression, and this is the rarefaction, and the compression again and rarefaction. Okay, now the distance between compression to compression is one wavelength or one lambda. Okay, remember, so this is what we call as compression, and this is another compression. So in the middle here we can see that the air molecules is far away from each other. So at this area we call as rarefaction. Okay, we continue to the next slide. Okay, as we can see here, there are two sources of sound waves. Right, this is number 1 and this is number 2. Alright, and this is the representation of the sound waves. And we can see that the white part is the rarefaction, in the line is compression. So this is rarefaction, compression, rarefaction, and compression. So these two sources, they are incoherent. Here I repeat, they are incoherent. So what is meant by coherent? So this is your homework. You need to find out what is the meaning of coherent. Okay, these two sources are incoherent. So we observe that when the compression from the first source, okay, made with another compression with the second source, when compression meets compression, what happened is it formed a constructive interference. So what happened when rarefaction meet compression? So we can see here when the one of the compression from the first sound wave meet with the rarefaction from the second source, okay, it will form a destructive interference. So we can see that this is one compression and this is the rarefaction. Okay, so it will produce a destructive interference where the amplitude equal to 0. Okay, so we can compare the amplitude between the constructive interference and destructive interference. So this is the representation. What is X? X is the distance from antinode to the next antinode. Alright, or to explain the antinode is when the constructive interference occur when a line meets another line from the another loudspeaker. Okay, so when the lines meets another line, so the constructive interference is formed, and it is denoted by a green dot. So along the green dot, okay, is the antinodal lines. So what is the nodal lines? Okay, vice versa, nodal lines form when constructive interference made with destructive interference. Okay, what is a nodal lines? Destructive interference occur, which is a line made with a zero amplitude. As I explained to you earlier, the nodal is denoted by blue X. So when at the area of blue X, it is a soft sound compared to the antinodal line. So we need to find the X. In this experiment, X is our responding variable and D is our manipulated variable and A will become our constant variable. Continue. Okay, can you recall the aim of the experiment? So the aim of the experiment is to determine the relationship between D and X. Right? So manipulated variable is D and X is our responding variable. So we can see that this is how we will arrange our apparatus. There are 2 smartphones and 1 speaker. But on Tuesday, I want you to bring 3 smartphones for one group. And then please install the frequency sound generator free apps into your smartphones. Okay, so what is the function of FSG, of audio signal, or as a sound generator? So it has 3 oscillators which generate 3 waveforms and oscillation range from 20 Hz to 20 kHz. So the frequency sound generator, eventually it will produce certain frequency that you desire. Alright, next, you need to install the advanced spectrum analyzer or any spectrum analyzer. And this is how we will arrange our apparatus. So the distance between 2 smartphones start from 30 centimeter. Okay, and then distance between the smartphones A and the distance between the parallel line where A and X is measured, which is D, is set at 20 centimeter and marked with a line. And then you turn on the frequency sound generator, okay, both of the smartphones at the frequency of 3000 Hz. A loud sound is heard from the smartphones. And then you move the other smartphones here along the line marked. And then identify, okay, the loud to loud sound distance, which is X in centimeter. Okay, next. Okay, this is our observation. So the distance between the loudspeaker to the parallel line of X is start at 30 centimeter, 40, 50, 60 to 70. And then we determine the distance between the 2 adjacent antinodal lines X. And lastly, we will analyze by plotting the graph of T against X. Alright, thank you. That's all. I hope that we can conduct this experiment next week successfully. And don't forget to study before you conduct the experiment. Right, see you. Bye. Assalamualaikum.